Hi guys, nice to see you again. Basically we were talking about coroutine last time in our last episode, 48. Um, we need, give me a moment. So we were talking about coroutine. Huh, here it is. So I was kind of stuck at this last time. I was wondering, so I understand that in this block, let me see if I can edit. No. So I just noticed that try Kotlin there's a new version of try Kotlin playground here. Yeah, this is so cool. So let's try this. So we can see that because we first run blocking and a coroutine is launched and there's a coroutine scope that is scheduled and launch and init and delay init. So basically there's a launch, so this is directly triggered. So this will happen after 200 milliseconds. And there's a coroutine and there's a launch and this. So basically this will also happen after 500 seconds. And there's a delay, and after 100 milliseconds this will be printed. So basically this will come first, text from coroutine scope, and then this one, text from run blocking, and text from nested launch. And finally, after this task, this subtask, this child of this coroutine scope is scheduled, is finished. Only at that moment this block would continue because it's in a run blocking, so everything is turned into synchronous. So this is synchronous, but because it is a suspendable suspend function, because this is a launch itself is a suspend function. Launch coroutine. It is, is it not? Oh, it is not a suspend function. It's actually something that is, it actually launches something and it has a suspend function. So anyway, so this is not, but coroutine scope itself is a suspend function, I believe. Kotlin. Nope, not this one. This one. Yeah, itself is a suspend function. So if it is run and run blocking, this will be turned into a non-suspending function, or anyway. So that's the reasoning anyway. So this is where we stopped last time. When there are two run blockings, the behavior becomes so weird, and I just asked my colleague, and his guess is in this run blocking, everything becomes blocking, and because this block is blocking, so this launch is on another thread and it is never, this is suspend directly after delay is called, but it will not resume until there's a other coroutine yields the priority to it. So because these are blocking, so everything here becomes are run directly on the with blockingly. So these just block the other coroutine. Maybe. And because everything is blocking here, so this is never the core is never returned to this launched coroutine. It is just like, hey, but how does it explain what happened here? Launch. This is also launched. So this is also launched, and so there should be some blockage here because this is launched, and for sure that there is going to be some this will be blocked here as well. So yeah, that's just his guess, but I don't know if it really makes sense. But anyway, his guess is these are run because this here in a coroutine, this coroutine just yield the core or the running power out, and everything is blocked later here, and only when everything here is finished, it again has the priority, and that's why this run test from run blocking comes in last. But theoretically, we would never do things like do run to run blocking. So I don't know. Anyway, so that's just so because we are still at the very beginning. I mean, we're just still coroutine newbies. So let's forget about it. So let's move on. So the point in this block is there's a scope blocker, scope builder, and taking coroutine scope as example, it is the main difference between run blocking and coroutine scope is that coroutine scope does not block the current thread. So this also, well, the change from coroutine to run blocking is also an example that illustrates that how there is indeed some difference between these two syntax. So extract function refactoring. Let's extract a block of code inside launch into a separate function. So this is just introducing the suspend function, I believe. When you perform extract function refactoring on a code, you get a new function with suspend modifier. Exactly, that is your first suspend function. Well, this is suspend is needed because delay here is a suspend function, and only suspend function can call suspend functions directly. Suspend function can be used inside coroutines just like regular functions, but their additional feature is that they can in turn use other suspending functions. This is just exactly what I've just mentioned, like delay in this example, to suspend execution of a coroutine. And yep, that's it. So, but what if the extracted function contains a coroutine builder which is invoked on the current scope? In this case, suspend modifier on the extracted function is not enough. Invoked on the current scope, making do world extension method on coroutine scope is one of the solutions. So it is again talking about I don't quite get what this means. Idiomatic solution is to have either explicit coroutine scope as a field in a class containing target function, or implicit when outer class implement coroutine scope as a last resort. Coroutine scope can be used, but such approach is structurally unsafe because you no longer have control on the scope this method is executed. What? I don't get it again. But what if the extracted function contains a coroutine builder? So I think this means that if the function contains like something like run blocking, I don't know if run blocking is one of the coroutine scope builder. But anyway, coroutine scope itself is one of it. So it is, if we're trying to extract this out, we can't do it with coroutine scope inside that suspend function. Can we? I don't know. In this case, suspend, it's just letting us know that suspend is not enough. Making do-word extension method on coroutine scope is one of the, what does it mean that, oh, extension method. Okay, that's the Kotlin extension. Coroutine scope is one of coroutine scope dot blah blah, maybe, but it may not always be applicable as it does not make API clearer. Idiomatic solution to have either explicit coroutine scope as a field in a class containing. Wow, this is just, I don't think we need to focus on this now at this moment. This is just too hard for us, at least for me now. So anyway, let's take a look at the next topic. Coroutines are lightweight. So if we repeat 100,000 times, if we launch a lot of coroutines, well, I don't get a chance to run that. Let's do it here and hope that the server is not going to complain about this. Is it? Well, there's still a GC overhead. Anyway, let's do it at 1000 then. Well, and that's it. So if we're doing some normal threading here, it's probably going to be broken. But because coroutine is lightweight and it does not really actually create a thread on your processor, it launch blah blah blah. After a second, each coroutine prints a dot. Now try with threads. Yeah, most likely your code would run out, have an out of memory error. But well, at this place, we get out of memory error as well. But hey, at least it can run some 10,000 version of it. Maybe not 100,000. But anyway, you get the point. So global coroutines are like daemon threads. Not quite. Wow, yeah, after 10s. Wow, it's just not capable of doing that. But hey, let's just do it somewhere else. So the following code launches a long-running coroutine in global scope. That means I'm sleeping twice a second, and then return from the main function after some delay. They are like daemon, just like I'm sleeping 0, 1, 2. It's just run in the background. That's the purpose of the global coroutine. And the most important of all, active coroutines that were launched in global scope do not keep the process alive. So they are like daemon, and let's take a look at this. This is definitely some interesting case. So probably, hey, it's not, oh my, oh, it's, yeah, it just prints twice. And after the whole block itself quits, it's just disappeared. So there will be no memory leakage in this case. Probably, at least that's, I believe, what it means. So let me take a look at this. Yeah, I don't see anyone in the chat, but anyway. So the next one, cancellation and timeouts. Am I just, I don't know. Is this the correct way to read it? I kind of feel like I'm jumping into a wild world that is just too hard for me. Let's just move on and see if anything is still makes sense to you and maybe to me. Cancellation and timeouts. This section covers coroutine cancellation and timeouts. And this really doesn't look like something that is suitable for a beginner for me. So canceling coroutine execution in a long-running application, you might need fine-grained control on your background coroutines. For example, a user might have closed the page that launched a coroutine and now it's reset and no longer needed and its operation can be cancelled. So this is just talking about why we are going to cancel a coroutine. The launch function returns a job that can be used to cancel running coroutine. And this means that let's take a look at this launch. Coroutine scope.launch. So it's an extension function of coroutine scope. So everything itself is inside the coroutine scope, I believe. So because it's an extension function, we can pass in a context. And if we pass nothing to it, it defaults to empty coroutine context. And there's also a start, and if we pass nothing into it, it defaults to coroutine start.default. So the only thing we will need to pass in would be a block of a block which is a suspend function which returns nothing, and this launch itself would return a job. So that's it. So it returns a job. So in this job we can do something. So this is definitely the suspend function that we have now. So repeat itself is a suspend function. Let's take a look at it as well. Repeat Kotlin. Nope, pretty much not this one. There it is. Yes, no. No, it doesn't look like this one. Repeat. So where is the repeat? R-E-P-E-A-T. Oh, it's okay. It's not a suspend function. It's a normal function. It's a normal inline function. So times, and there's also an action, and this is applied with a lambda. So this part is repeat for n times. Repeat 0. Interesting. So yep, this is not a coroutine. This is not a suspend function, but with these, it is probably becomes a suspend function. I'm not quite sure about it yet. But yeah, anyway, so this thing is launched, and for every 500 milliseconds. Okay, so it runs a lot of times. And so we print loan for 2 times probably, and then we cancel the function. And after that we block everything, block the main thread, and after that, after it is cancelled, it can't be. So probably we'll see 2 or maybe 3. I'm sleeping here. 0, 1, 2, yeah. Oh, so 0 and 501 and another 500 milliseconds and 2. And after that we print I'm tired of waiting. And after that we cancel the job, and well, if we join without canceling, this is going to be pretty disastrous. Let's run it in a playground as well. So let's try it first. Okay. So this is not a running example, or at least we need a main. That's probably it. Oh, okay, we need another suspend function. Interesting. So let's call it let's write a function for it. Suspend function, whatever. That's it. Okay, unresolved reference. I think it is caught in a coroutine body, but okay. I now don't get whatever is happening now. Launch. Launch is unresolved reference launch. I think I've imported everything already. That's weird. I don't know, what version is this one? No. Yeah, I know we already have it. Oh, interesting. So that's not the... So why is this working? That's so weird. Okay. Yep, probably that then. No main function found in project. What? What? Why? Why do you think there's no main function? There is one. Come on. Ah. Oh, that's some source of that. Well, it's somewhere between that. Could be an invocation target exception. Let's see if this is still going to work. Okay. I think I get it. No, I don't get it. I didn't get it. No main method found in project. Why? This was working well. This was working well as well, but I don't know why. So that's probably something we should have tried. Oh, this itself is... Okay, let's do it this way. It's not printing anything, probably because global style of this whatever is discarded. So let's delay a lot here. Can't call delay. That's it. So, yep, I'm slipping 0, 1, 2, and now I can quit. So if we join directly, this is probably going to be disastrous because this is going to be blocked forever. But anyway, because red.sleep is called anyway, I mean, because we exited this function after 3,000 seconds, because global scope, just like what we mentioned today, is what is like a daemon. So it will be force cleared or force exited after the main returns. So that's probably everything for today. Wonderful, right? I know. So yeah, I think we're going to move. We're going to stop here, and so that next time we can just talk about cancellation and timeouts. So that's probably over today. Let me take a look at it. So this is the first time we're finishing everything earlier than expected for quite a while, but yeah, that's a good thing. So let's see, is there anyone still live and would like to ask something? I'm gonna wait for just like 1 more minute, and if no one is going to ask questions, I'll probably leave early today. So yeah, I really recommend this Kotlin Playground. Play.kotlin.org. This is excellent. I like the interface. So, JetBrains just write wonderful IDEs. So yeah, no wonder. That's why. So nope, I still don't see any questions now. So let's just make it a day. So we will be writing more Kotlin code tomorrow. Write some extra code and read some manual. That's what we do now. So that's all for Learning Kotlin Live episode 48, and bye bye. Bye guys.